Hello and welcome to our squeeze class. Today we're going to learn about transformations and even and odd functions. Now in this situation, if we have y or f of x equals x squared and I have a negative f of x, what this does is it flips it over the x-axis. So the function will look something like this. So if that occurs, uh, what changes? The domain, the range, both, or neither? Well, the domain is going to stay exactly the same. So it's not the domain. But the range, instead of going from 0 to infinity, now it's from negative infinity to 0. So the range is going to change. Now if we take this function, square root of x, this would move it to the left 6, and this would move it up 3. So if I go to the left 6, up 3, and now I make the graph. Let's see how that domain and range match the original. So this is f of x. This is our new function, f of x plus 6 plus 3. Now the domain changes because instead of going from 0 to infinity, it goes from negative 6 to infinity. And the range changes because instead of going to 0 to infinity, it's going 3 to infinity. So that is both. Now if we take 10 to the x, which is a function that looks like this, if we move it to the right 2, it's just going to, I'll do this in a different color, it's just going to look something more like that. So that's not going to change the domain or the range. All right, now here we're going to move this piecewise function. This one translates up 2. So each coordinate, I'm just going to move up 2 points. This one moves to the left 2. Now this one reflects over the x-axis. So we just take the point and it's 2 down, so we'll go 2 up, and now we just connect the points. And this one's going to reflect over the y-axis. So instead of being 2 to the right, we go 2 to the left. Instead of being 1 to the left, we go 1 to the right. Oops. And then instead of being 4 to the left, we go 4 to the right. All right. Now this is a vertical stretch, where this is a horizontal shrink. Now, a lot of people have a hard time telling the difference between the two, but if you do it on a piecewise function, I think it's pretty clear what happens. On a vertical stretch, we multiply all of the y values by this factor, in this case 2. So this y value is 0, 0 times 2 is 0. This y value is 3, 3 times 2 is 6. Here, negative 2 times 2 is negative 4. So when I connect these, you can see this stretches vertically. Now a horizontal shrink by a factor of 2, we take each x out value and divide by 2. So 2 divided by 2 is 1. Negative 1 divided by 2 is negative 1/2. Negative 4 divided by 2 is negative 2. And there you go. Now on this one, we have, we're going to move it up 1, flip over x, and then stretch by 2. So first let's stretch it by a factor of 2. This one would be up here, here, and here. Now, I'm going to use a blue dot to flip it over. So instead of being up here, it's going to be, instead of being up 6, it's going to be down 6. 1, 2, 3, 4, 5, 6. That's 4, so 1, 2, 3, 4. And this one stays where it's at. And now my green dot, I'll move each of these up 1. So my red dots were just stretching by a factor of 2. Then my blue dots are what happens if I flip it over the x. And then finally I move it up 1. So now I'll connect my green dots and have my new function. This next one, we shrink by a factor of 4 and flip it over the x-axis. So if I shrink by a factor of 4, 2 divided by 4 is a half. 1 divided by 4 is 1/4. 4 divided by 4 is 1. Now I flip those over the x-axis, and now in red, I will have my points. So now I can connect them, and this is my new function. Now we're going to look at absolute value transformations. Now, if I would graph these on my calculator, let's wait for my trusty calculator to come up. All right, so I already have these in here, so all right, at some point it'll settle down. All right, to graph this first function, I'll just leave that one on, and you can see what it looks like. So the original function looks like this. This is my original function. Now, when I graph the absolute value of that function, that's what I'll do for the second one, and I highlighted it so we can see what it looks like. We take our function, and where it's positive, it just traces it, but where it's negative, it reflects over the x-axis. So that is going to be my absolute value of f of x. Now, if I want to find f of the absolute value of x, we do this. And it looks like that. So what it does is it traces the positive x and then reflects that over the x-axis. And we just ignore the part of the original f of x where it was negative for x. All right, so let's try this with a piecewise function without a calculator. So here we're taking the absolute value of the h of x. So all of the positive y's stay exactly the same. But where the y becomes negative, it flips up to being positive. So positive y values are not changed. That's changed. Negative y values are reflected over x-axis. Now over here, the positive x values stay the same, and then those values are reflected over the y-axis. So positive x values stay the same, but negative negative y values, negative r. Maybe I don't like the way I said that. The positive x values stay the same, but and uh, uh, are reflected over x-axis or y-axis. There you go. All right, so if I take the absolute value of h of x and then move it up 2, it would look like that, but each goes up 2. So maybe it even helps to draw this out initially. And now let's go to blue. And the blue is what we're looking for. I'll erase the red. All right, so the absolute value of h of x would be this. And then I flip that over the x-axis to make it look like this. So I'll erase the original. And there is our graph. Now, even and odd functions. This is an even function and this is an odd function. An even function reflects over the y-axis, where an odd function, we can rotate it 180 degrees, and it's the same function. Same thing here. This is an even function. Reflects over the y-axis. I don't know why I rotated it. This one is an odd function, and if you rotate it, it looks the same as the original. And here are the functions. Notice that the functions in an even function, all of the exponents are even. And this we could even say is x to the 0. And here all of the exponents are odd. This is 3 and 1. A function f is an even function. So if we look at it graphically, it reflects over the y-axis. Numerically, we can look at this definition. It's an even function if and only if f of negative x equals f of x. So what it's saying is f of negative 2. So if negative 2 is 8, 2 has to be 8. If negative 1 is 4, 1 is 4. 0 is 2. There's no negative 0, so that's just where it's at. Algebraically, all of the exponents have to be positive. Or not positive, but even. Both of those would be even functions. And remember, if there's just a 2, that's like an x to the 0 power. Here, if we're dealing with odd functions graphically, we can rotate 180 degrees and it's the same function. Numerically, we can look at the definition. F of negative x equals negative f of x, which is somewhat confusing to people. If we have 2 is equal, negative 2 goes to 8, 2 would go to negative 8. If negative 1 goes to negative 4, 1 would go to 4. So it's always the opposite of the other one. And we could go 0, 0. Algebraically, it would be like 3x, because that would be x to the first. Y equals 5x to the third plus 4x. Both of these would be odd functions. I didn't try to put that there. Now, if we want to complete this to make it an even function, what we would have to do is make it symmetric over the y-axis. So if this were to be an even function, what we would have to do is swing this down here and then continue this to the axis. To make that an odd function, we would have to say if there's a point 3, 3, there would have to be a point negative 3, negative 3. This point is 2, 1, so negative 2, negative 1. So it would look something like this. And then this point is at the end in 0, so this would also have to be negative that in 0. So, and now if you take a look at this, if we could rotate this 180 degrees, it would be the same function. Here, to make this an even function, this would have to reflect over to there. This would have to reflect over to this side to make it look like that. And you can see now it's symmetric. To make that an odd function, the point 3, 2 would have to be negative 3, negative 2. And the point negative 3, 2 would be 3, negative 2. And so it would go out like that. All right. Now it is time for your homework. Good luck.